Okay, so for this one, we're dealing with three amounts. We have the original price. We have a discount that we removed, that we subtracted. Then we have the amount that we paid. The original price, of course, is always 100%. We subtracted 9% for the discount, which means the amount we paid is 91%, 100 minus 9. And we know on the other side that the amount we paid is the $3,822. So we know we're going to use this because we know both the percent and the dollar amount that describe the amount paid. The question is, which other one are we going to use? And that, of course, comes down to what we're being asked to find. Here we're asked to find how much did you save, which is the amount of the discount. So what we're really comparing here is, we're not even using the 100% at all. We're comparing the amount of the discount, which was 91%, to the amount paid. The amount of the discount, which is 9%, to the amount paid, which is 91%. So if we cross multiply and divide, 9 times 3822 divided by 91 gives us $378. So $378 was the amount of our discount at the 9%. If we wanted to keep going, we could find then that $4,200 would have been the full amount. Many of you may have gone about it that way rather than doing the table. You may have just found the amount paid is 91% and used that to find the full amount of $4,200 and subtracted back out to get to the $378. How many of you got the $378? A few of you? So we're still struggling a little bit with those increase problems. Those are kind of tricky. The key to remember is you have to ask, is the number we're given before the increase or decrease, or is it after the increase or decrease? And if it's before, then it's great. It just matches up with the 100. But if it's after, then we have to make sure we adjust its percent. Okay, today I want to take some time. There is going to be a quiz today on percents at the end of the hour. So I want to take some time here in the beginning to wrap up some other applications. We had mentioned last time commissions and stuff like that. I want to take a look at another important one, which is interest. And we're going to throw a couple formulas out there. We're going to talk mostly about simple interest. And I may have mentioned this a little bit before. Simple interest is the simplest way that you can calculate interest on an account or a loan or whatever. And in simple interest, the interest is only calculated either at the end of the term or at the end of the time, or when there is an action. When an action occurs. Now, by an action occurring, what I mean is either money has been paid in or money has been drawn out. Most of your home mortgages, car payments, and stuff like that, even though the interest does build on them, they're actually simple interest because they only figure out the interest when you make a payment on that loan. So even though that they're not going to let it sit there forever without interest calculated, it is still considered simple interest. So let's take a look at the formulas for this. The amount of interest over a period of time is I, is that amount, and it's equal to the amount of the principal, which is P, times the rate, which is our percent as a decimal, times our time. And our time, of course, is in years. That gives us the amount of interest earned. So if I have an investment, let's say that you're going to invest $3,000 at 8% for 3 years. The amount of interest earned, well, our principal is the starting amount, the $3,000, times our rate is the 8%, but we have to convert it to a decimal, so 0.08, and our time is 3 years. So that comes out to be $720. Okay, so we get $720 in interest for that 3-year period of time. The next step is, how much is it worth at the end? The fancy term for this is called the maturity value. If it's an investment, it's the amount of money that you will get back at the end of the investment. If it's a loan, that's the total amount that you would have to pay back in at the end of the investment. Our maturity value is just equal to our principal plus our interest. So for a problem that we just did, that maturity value is the $3,000 we started with plus the $720 in interest. So $3,720. Now this problem that we just did is not terribly practical because we went 3 full years without doing the interest. We calculated the interest for all 3 years all in one big chunk. And that's how simple interest works. It's all done at once. But generally a bank doesn't do simple interest for something as long as 3 years. Usually they won't do simple interest for anything longer than 6 months. If it's longer than 6 months, they like to do what's called compounding, where they calculate the interest, they add it to the account, and then there's interest calculated on top of that interest from there on out. So usually simple interest is for shorter term things. Like, oh, let's say that you're going to borrow $2,500 at 6% for 3 months. I've had to do this a few different times. Working on a larger job and you don't finish up, you do have partial payments that come in as you progress through the job, but you're at a point where you don't have a payment coming in. It's the end of the 2 weeks and it's time to pay your employees. You need to take a small loan so you have enough to pay them until you can get through and finish the job and collect from the customer. So let's look at this. First, let's figure out how much interest is going to be calculated. So I is going to equal, our principal will be $2,500 times our rate of 6% becomes 0.06. So the tricky one, before we had years, so we just put 3 years. This is 3 months. And we said before that our time is always in years. Well, there's 12 months in a year, so I'm just going to express that as 3/12 of a year. So now to enter this into the calculator to calculate it, I don't have to worry about that being a fraction. I'm just going to enter in 2,500 times 0.06 and times 3 divided by 12. So $37.50 interest. So to have that $2,500 for 3 months to pay my employees, it cost me $37.50 interest. Now, if they were to ask us how much I have to pay back at the end of the 3 months, that would be my maturity value. The $2,500 of principal plus the $37.50. So $2,537.50 would be the maturity value. Let's do one more example. Oh, let's say that you are going to invest $8,000 at 2% for 6 months. Now, I don't say 2% simple interest, but we're assuming it's simple interest. Let's figure out now this time, rather than just finding the interest, I'm just going to jump straight to let's find how much we have at the end of 6 months. How much are we going to get back at the end of 6 months? We still do have to figure out the interest first, but it's not what we're asking for here. So the amount of interest, what numbers am I going to put in here? What comes first? 8,000 is my principal, good, times perfect, 2% becomes 0.02 times what goes in for my time? 6 months, 6/12, or 1/2 if you wanted to. So we multiply that out. 8,000 times 0.02 times 6 divided by 12 is $80. So I still have to find how much I have at the end. So that maturity value is what I'm looking for. It's the 8,000 plus the 80, which is $8,080 is how much we'll have at the end of the 6 months. Now, unfortunately, even 2% is kind of a high interest rate for a 6-month investment right now. Let's have you guys try one. Let's say you're going to borrow $5,000. They're going to charge you 9% for 4 months. Figure out for me in your notes quick how much we would have to pay back at the end of 4 months. So our first step is to find the interest. Principal of $5,000 times 9% becomes 0.09. 4 months would be 4/12 of a year. That comes out to be, what, $150 in interest? Perfect. So then what we would pay back is the maturity value, 5,000 plus 150, 5,150. So now I've only went down as far as calculating it down to the month like this. You could go down to the days. There's a difference between a 3-month loan and a 90-day loan. We're not going to get into here. If this were a business math class, we'd take the time to look at calculating the interest per day and stuff like that. We're not going to get into that and the different types of interest. But I do want to show you guys an example. Let's say that you have a car loan. And you have a $10,000 car loan. And you're getting charged 8% interest. Now, I'm going to cheat and I'm going to put this into a spreadsheet for us so we don't have to do it all by hand. But let's say you have a tax refund or something at the beginning of the year, and you could make 4 or 5 car payments. Now, what would it save you? So I'm going to pull up a spreadsheet here. Maybe I'm going to pull up a spreadsheet. And what I want to compare is what the difference would be if I paid a large amount now versus if I made my monthly payments every month. Let's just do 5 months here. So let's say you get your refund in February. So we'll start out with March. And we'll go from March down to July. So let's start out with what you pay every month. So we're going to have our payment. There we go. Our payment and our balance. So we'll start out with $10,000. So in March, we go to make our $500 payment. Before they figure in the payment, they're going to figure in the interest. Now we said 8% interest. So the amount of interest that's going to get figured in, I'm going to move this over, is going to equal that $10,000 times 0.08 times 1 divided by 12. We're just going to do 1/12, considering all months are the same. I want to format these for currency so I don't have to worry about rounding here. My Excel program seems to be having some major issues today for some reason. There we go. Okay. So then my balance is going to equal my $10,000 plus my interest minus my payment of $500. So after that first month, I'm down to $9,566. So I make another payment. I'm going to have my interest. It'll be this amount times 0.08 times 1/12. So again, this will equal the previous month plus interest minus the payment. Fill down our interest, and we fill down our balance. So in the month of July, after we make our July payment, our balance would be down to $7,804.25. Let's see what would happen if we make this payment all at once. I realize you wouldn't often be able to do this. You wouldn't often have that kind of money available. Let's say you just got your tax refund, like we said, in February. So in March, you are able to pay $2,500 all at once. You still have your $10,000 that you're starting with. Your interest. Well, we're only paying interest for the first month here at this point. So our balance will be the $10,000 plus interest again minus the payment. So our balance goes down considerably because of the $2,500 payment. Now, we're not going to pay anything then until August. Well, I guess we do have to add August to this. I should have stopped at June and only did 2,000. That's okay. So in August, then we'll go back to making our regular $500 payments. Well, during these months here, since you didn't make, I said before, your car loans are done on simple interest. Since I didn't make a payment, the interest isn't figured in. The interest doesn't get figured in until here when I make this payment. That payment, now the interest, they're going to still add in interest for all 5 months. It's just going to happen all at once instead of building on each other. So it's going to be that balance times 0.08, but it's going to be times 5/12 because it's 5 months worth of interest sitting there. So now we end up with that balance plus interest minus our new payment. So after the August payment, you can see what has happened here. Now this is at 8%. If we had made that one big payment in March, made 5 months worth of payment at once instead of making them individually, we would be about, was it coming like $38 ahead, not quite $38 ahead, by making that one payment all at once. Now looking at that, you can see, everybody says, well, make your payments ahead, save the interest. Well, here's the case. It shows you that 5 months worth of payments is only worth about $38. I'm not saying you shouldn't pay ahead, but it's not that huge benefit that you might think. Now, the next application I want to show you is going from simple interest into compound interest. So as we've seen with the examples we've done on the paper here, we didn't figure out any interest till the end of the term, until the time was up. The example I just did in the spreadsheet, that was still simple interest. They figured out the interest every time a payment was made. And when you didn't make a payment for 5 months, they didn't figure out the interest for 5 months. Well, compound interest, that interest is figured out at regular time periods, whether you do anything or not, whether you make a payment or not. So we're going to look at compound interest. It can be monthly, so they figure out the interest every month. Quarterly, they figure it out 4 times a year. Annually, those are the 3 most common. Some of your larger banks will do daily interest. That was a fad for a while, about 10 years ago, and it's kind of faded away. Well, let's take a look at that first example we did up here of $3,000 at 8% for 3 years. But we're going to make a little change. It's going to be $3,000 at 8%, but compounded quarterly for 3 years. So what this means is each quarter of a year, 4 times a year, the bank is going to figure out the interest and add it on to the balance of this loan. So in quarter 1, the amount of interest is going to be that balance of $3,000 times my rate is 0.08 times my time is going to be 1/4 of a year, so 1/4. So I figure that out. What do I get? $60 of interest. So what that means, take 3,000 plus 60, my ending balance there is $3,060. And I start quarter 2 with $3,060. So my interest, $3,060 times 0.08 times 1/4 is what? $61.20, I believe. So we add that on, we're at $3,161.20. How many times am I going to have to do this to get through my full 3 years? Quarterly is 4 times a year. For 3 years, that would be 12 quarters, 12 times. I don't really want to do this 12 times. So I want to find a shortcut for doing this. So let's take a look at this. Each quarter, I start out with a beginning balance. And to that balance, I add interest to it to end up with an ending balance. So if I look at my beginning balance is 100%, the interest is not 8% because we're only figuring out 1/4's worth of interest. If I look at this right here, 0.08 or 8% times 1/4, that comes out to be 0.02 or 2%, which makes sense. If that 8% is annual interest, 8% per year, each quarter, or each 1/4 of a year would be 8 divided by 4 or 2%. So I'm getting 2% interest each quarter. So my ending balance at the quarter is 100 plus 2, or 102%. So if I found 102% of the starting balance, that should give me my ending balance. Let's check that out. Let's do our first quarter, 3,000. Now I'm still going to use a rate. Instead of multiplying by 102, I'm going to multiply by the decimal, which is 1.02. That's 102%. And that does give me $3,060. If I do that again for quarter 2, take my 3,060 times 1.02. Do I get $3,161.20? Yes, we do. So that works. I can just take each quarter and take the beginning balance times 102 to get my ending balance, 102%. How many times again do I have to multiply by that 1.02 to get to the end of my 3 years? Well, again, 4 quarters times 3 years, still 12 times. So basically, I could start with my $3,000 and multiply by 1.02 12 times. In math, do we have a mechanism for multiplying by the same number over and over again? Yes, we do. It's a power. So we can take that 3,000 times 1.02 to the power of 12. Get 3804.73. $3,804.73. Now, if you compare that to what we had, remember our first example for simple interest, we had $3,720. So we end up being $84.73 ahead because of the compound interest. Now that over 3 years, that's a significant number, but it's not huge. But compound interest really has its effect over time. I'm going to assume that you guys, since you're in high school, are 18 years or younger. So let's just say 18 years old. Right now, for your age group, minimum retirement age is going to be 68 or 69. So let's just say 68 years old to retire. And now you're at 18. That's 50 years. So we're looking at waiting 50 years between now and retirement, which, yeah, I know that's kind of a depressing thought. But something promising for you. Being young, you have something working hugely to your advantage here. How many of you have money saved up for college? A few of you do, okay. Well, you are allowed to use some of that money for retirement accounts. Even if you don't have money saved up for college, you're allowed to take other money into retirement accounts. The condition is you can't put away more than what you earn. So how many of you have a job? So quite a few of you do? Okay. So let's say you go out at your job and you earn $2,000 this year. And rather than spending it, which I know you're going to have expenses like your car and stuff like that, gas and everything. Well, let's say that let's say you make more than $2,000, and by the time you spend your gas and all that stuff, you're able to save $2,000. I just want to use 2,000 to make it easy on myself. So you want to save $2,000. This is at 18 years old. If you put that money into a retirement account and let it sit there from age 18 to 68. Now, I realize if you go to the bank and put the money into a CD or a bank account, you're going to get like 0.2 or 0.3% interest, less than 0.5% interest. But if you go to a professional investment planner, something other than savings accounts, not necessarily stocks, but it could be stocks, bonds, mutual funds, something that gets a little bit better return, maybe a little bit more risk, or a lot more risk, you can do a lot better than that 0.5%. Right now, the average annual gain for any 40-year period in our stock market is between 12 and 13%. That even includes periods like in 2008, 2009, where we had the huge crash. It includes periods in the Great Depression in the late 1920s and early 1930s. So, I mean, that 12 to 13% seems pretty consistent. For you guys, let's say we're going to do 10%. Let's be conservative. So now at the end of each year, you have your original amount plus 10%. So at the end of each year, you have 110%. So to make this simple, we're just going to compound annually. We're going to compound once every year. So we're going to multiply your $2,000 times 110%. But we're going to have to write it as a decimal. So it'll be 1.10. That's each year. So at the end of the year, it'll be 110%. And we're going to do that each year for 50 years. Now, before I punch this in the calculator, anybody want to guess how much money you're going to have in 50 years? It's actually a lot bigger than you'd expect. That $2,000, and even just 10%, just turned into $235,000. $234,781. How many of you would like to be a millionaire when you retire? Nobody? I was going to say, I thought that was a pretty easy question. There's one guy in the back of the room that says, hell yes, I want to be. This is, $234,000 is almost a fourth of the way there. If you do, starting at 18 or 19, put away $2,000 every year for 4 or 5 years, you're looking at being either a millionaire or really close to it when you retire. Now, let's say you get out of high school, you're going to want to play with your money a little bit, you go to school or whatever, you get out of college and you get a good job, and then you want a new truck, you want snowmobiles, four-wheelers, whatever. So you mess around, you play with your money until you're 28. Then at 28, you decide, okay, now I'm going to start putting away money. So you put away that same $2,000 at 28 years of age. Well, now it's only going to sit there for 40 years. So we'll do the same calculation, but only going for 40 years. You only get $90,518. 519 technically if I round it off. You're getting almost down to a third of what you would have if you'd have put it away at 18. Let's say you wait another 10 years. At 28, I'm too young yet. I'm going to maybe buy a house or whatever. I'm not saying buying a house is a waste of money, by the way, but I've got other things I want to do with my money. I'm going to wait a while. So you wait another 10 years till you're 38 and put away that $2,000. So now it's only going to sit there for 30 years. Oops, something went wrong there. I got an extra zero in it. Yep, I messed up. Here we go. There it is, $34,899. So now we're down to less than an eighth, about a ninth of where we started. So, I mean, every 10 years is costing us about a third of where we started. Let's say you really mess up. I'm 43. So let's say you wait till you're my age, 43 years old. Now you have to start worrying about retirement, right? So that's only 25. No, you don't. Just you're gonna work till you die, right? I've often told people my retirement plan is a massive coronary at about 70 years old. That's the only way I'm gonna get to retire. Okay, there we got it. This comes out to be only $21,669. So you compare that to where we started. You're less than 1/10. You're about 1/11th of the money you would have had if you'd have put it away at 18. This is a significant enough. Oops, is my computer screen still showing there? We had a flicker. It's still showing? Okay, good. Let's, well, we'll see if my spreadsheet will pull back up. Hey, there it goes. This is significant enough to show you a long example. So let's start out age 18 with you guys. Now, what I just showed you, that's only putting away that $2,000 once and letting it sit there until you retire. Now I want to look at what happens if you put it away more than once. Let's see. So let's say you put away that $2,000 every year up until you're 68. Anybody want to guess how much you're going to have at 78 or 68?
Oh, you were way off, Janet. What are you close?
Over $2.5 million. Think about it. $2,000 a year is only about $180 a month. So it's not a tough, it's $90 a paycheck. Now let's do this. Let's do some scenarios. The first one I'm going to do is what I was just talking about. You're starting out at 18, you're going to start saving. You know what? You're young. You can live cheap. You don't need to be real fancy with your life. So you start out at 18, you put away $2,000 a year until you're 27. So that's 10 years you put it away. So starting at 28, you decide, you know what? From here on out, I'm going to play with my money for the rest of my life. I'm not going to save anymore. I've already put this money away. Do you think that's going to make a huge difference in how much you have when you retire?
Oh, yeah.
Think it's going to put you under $1 million?
Yeah.
Actually, still at almost $1.5 million. Let's look at the other side. Let's say at 18, you decide, you know what? I'm young. I want to play. So you don't put anything away until you're 28. Then you start at 28 and you put away $2,000 every year until you retire at 68. Do you think they're going to end up more or less than that 1.5 million? Here you save for less. Okay, here you save for 10 years Over here, we're going to be saving for 40 years. But you're absolutely correct. You come out to be much less than $1 million. Now, if you look at that, starting at 18, I mean, you guys are at that right age. That first 10 years of your life is worth more than the next 40 years as far as saving for your retirement. In fact, let's see if we can balance this out. Let's go back a year. So you only save for 9 years. Let's cut it off. So at 26 is the last year you put it away, and you start saving. This person starts saving at 27. Still not equal. Still 1.4, almost 1.5 million here, and just over 1 million over here. So let's say this person only goes for 8 years. So our first person over here started at 18, only saved for 8 years. So from 18 to 25 and then stopped saving. This person started saving at 26 and put it money away for 43 years until they got to 68. Still does not catch up. And it's a pretty impressive buildup of interest, if you ask me. Let's go back one more. So this person only saves for 7 years, from 18 to 24. This person starts at 25 and saves for 44 years. Now they finally end up with more, but not much, about the same. So this first 7 or 8 years of your life, the next 7 or 8 years of your life are worth more to your retirement than the next 40 or 45 years. So I'm not telling you what to do, but just something to think about. It's something that I always put out there every year just to make sure you guys have seen it. Starting young makes a huge difference. Now, there are formulas where we could calculate what I just did in that spreadsheet, but that's beyond what we want to do for this course. What I want to do is I want to take about 15 more minutes looking at these percent increase and decrease problems and see if we can get through some of the hang-ups of those. I know they're very difficult. It's hard to do. And then we'll give you some time to get your quiz done. So, yeah, I know that's just what you want to do, right? Quizzes? So anyway, let's say that you receive a 12% discount. How much do you pay for materials list price or listed at $1,800? So here, we're having a discount. So this is, the first thing we have to ask ourselves, is this an increase or a decrease? Does a discount, does that add to 100%? Or does that subtract from 100%? A discount will subtract. So we have 100%, which would be our starting amount. In this case, that'd be the list price. We're going to subtract 12%, which is our discount, which would give us 88%, which is going to be our final amount, our ending amount, which in this case will be the amount paid. So now we have to ask ourselves, this $1,800, does that represent the dollar amount before the discount or after the discount? That is definitely before the discount. So does that match up with the 100%? Yes, it does. So we can use that 1,800 with the 100%. Now we're looking for how much we're going to pay. That would be the ending amount, the 88%. So here we have two options. I mean, the 1,800 is going to go with the 100% in our proportion. Notice they link together so they're across from each other. We can either find the 12% and subtract it, or we can just go straight to finding the 88%, which is what I'm going to do. So we're going to cross multiply and divide. 88 times 1800 divided by 100. Perfect, thank you. 1584 is exactly right. So that's how much you would pay after discount. This is the simple version. Now it is a decrease, so we had to subtract a percent from 100. But it's the simple version where we are given the dollar amount or the amount that goes with 100%, that starting amount. The difficulty is when we're not given that amount. So let's say that after a 10% discount, you pay $468 for materials. I'm going to ask, how much is full price? So again, this is a discount, which is telling us it is a decrease problem, percent decrease. We're starting with our 100% and we are subtracting the discount, the 10%, which gives us 90%. So we need to figure out what matches up with each of these items. The 100% is the before the discount. The 10% is the amount of the discount. The 90% is after the discount. So over here, the $468, is that before the discount or after the discount? After the discount. Good. So that goes with our 90%. So now here we're asked to find the full price. Full price would be before the discount. So when we set this up to calculate, we're going to use the 90% with our 100%. Does the 468 go on top or bottom? Careful. Yeah, the 468 represents the after, which is also represented by the 90%. So the 468 and the 90% have to go together. We're looking for the amount before the discount, or the full price. That has to match up with the 100%. So that has to be down here. So we will cross multiply and divide. 100 times 468 divided by 90 is what? 520? So 520 is the full price. Is that what we were looking for? Yes, we are. 520 is our full price. Let's say after a 5% discount. You pay $760. How much did you save? So now again, it is a decrease, being a discount. So we start with 100%, and what are we subtracting this time? $5 discount, right? So which means we end up at 95%. And just like before, the 100% represents the before the discount. 5% represents the discount. And 95 represents after the discount. Okay, good job. So here we're given the $760. Does that represent the before or after? That's after, right? Now here, we want to know how much we saved. That lines up with the discount. We could go ahead and just use the 95% and we could find the amount before and then subtract to get what we saved, what the discount is. That's just fine. Here, I would probably just use these together just like they appear here. I'm going to leave the negative off my 5% though. So 5 compared to 95 is equal to my missing number compared to 760. And you are absolutely correct. When you cross multiply and divide, that comes out to be 40. Or you could have done the 95% out of 100. 760 goes with the 95 because they're both after the discount. And if we cross multiply and divided, you get $800 was full price. Then you'd subtract to get the 40. The key is you have to remember the 760 does not represent the same thing as the 100%. It is after the discount, so it is no longer linked to 100%. It is whatever percent is left over after that discount. So let's look at the other side of it. Let's look at increases. Let's say you special order $800 worth of materials. You are told there will be a 7% special order fee. How much will you pay? Perfect. Great job. This one's straightforward. We have our 7%. This is going to be an additional fee. So we start with our $100 or 100%. We are adding a 7% additional fee to it. So the amount that we pay is 107%. This is an increase problem. So again, we have the 100% is the amount before. The 7% is the extra fee. And the 107% is the amount after. And here the amount we're given, the $800, is the amount before. So that does match up with the 100%. And we could have gone one of two directions. We could have gone the 7%. And of course, the 800 matches up with the 100. You could cross multiply and get the amount of the fee. Or you could have just done 107%. And cross multiplied to get the amount of the fee. Well, the total amount in this case is $856. Very good. But again, that was straightforward because the number we're given, the dollar amount, matches up with the 100%. It's when it doesn't match up that we end up with difficulties. So we might have, after a 9% fee, you pay $545. How much was the fee? So again, you have 100%. They're adding an additional fee onto this. So we're adding 9%, which brings us to 109%. So the 100% is always the before, the starting amount. The 9% represents our fee. Not free, but fee. And the 109% is the after. Is the $545, does that represent the amount before the fee or after the fee? After. So that represents the 109%. So if we set this up, 109%, would the 545 go on top or bottom? Top. Very good, because it matches up, represents the same thing as the 109. If we cross multiply and divide here, we get 500 bucks. Now, is that what we want? Is that what we were looking for? No, we wanted the amount of the fee. So we would subtract 545 minus 500 to get a $45 fee. We could have, if we'd have noticed it, obviously we're going to deal with these two numbers because we know both sides of that amount. If we knew that we were going for the fee, we could have just gone straight for the fee. We're comparing the 9% fee to the 109% total amount paid. And of course the 545 goes with the 109. And if we had cross multiplied and divided here, we would have got 45 bucks. Is the amount of the fee. So let's say that after 6% tax, you pay $901. How much was the cost before tax? See if you can figure that out in your notes for me quick. So we started out, obviously we start out with 100%. Are we adding the 6% or subtracting it? Taxes is going to be added. You got it. So we're adding 6% to get to 106. So again, the 100 is before. The 6% is the amount of the tax. 106 is after tax. Does the 901 represent before tax or after tax? After tax. We want to find what the cost was before tax. So what we're looking for actually is the 100%. So this one, there's only one way to approach it. We have a 106 over 100. What numbers go over on the other side here?
901 can go up on top.
Perfect. 901 goes up on top because it matches up with the 106. If we cross multiply and divide, 100 times 901 divided by 106, the 850. Perfect. $850 is the price before tax. Okay, so let's say that after a 13% surcharge, a surcharge is in some cases another way of saying tax. Like if you check into a hotel, it may advertise $59.99 a night. Then you pay, it's like $71. Those are surcharges that are added on it. Those are forms of taxes. So let's say after a 13% surcharge, you pay $339. How much was the surcharge? See if you can find that one for me quick.
Answer would be $39.
$39? Good deal. Perfect. See you started out with 100%. You're adding a 13% charge to it, getting up to 113%. 100 is the before again. 13% is the surcharge. 113% is after. And 339 is also after. What we're looking for here is the amount of the surcharge. So I would just compare the 13 to the 113 with the 339 on bottom. Cross, multiply, and divide. You do get $39. Good job. Any questions on those percent increases and decreases? Hopefully they're becoming a little bit clearer for you. I know it's a tough concept. In your little book, Unit 17 goes through this interest. It does go through the simple interest, and it gets into some of the compounding interest. It doesn't use the same formula I did. It just goes calculating the interest every period and adding it in. So if you don't feel like doing more than one or two of those, I totally understand. When it comes to the test, there will be one compound interest question on there, just so you know. And it'll be 2 years semi-annually. Semi-annually means how many times a year?
4.
Twice. So that's every 6 months. Okay. There is a quiz for you guys to do today, so I'm going to give you guys the last 20, 23 minutes here to do the quiz and then get started on the homework. Next class, I won't see you this Friday is in service, right? Or parent-teachers conference?
Parent-teachers, yeah.
Parent-teachers conference. So I won't see you again until next Wednesday. Next Wednesday is going to be our Unit 1 test.